Oil of kinematic viscosity 1 into 10 to the power of minus 5 meter square per second flows through a pipe of 0.5 meter diameter with a velocity of 10 meter per second. Water of kinematic viscosity 0.89 into 10 to the power of minus 6 meter square per second is flowing through a model pipe of diameter 20 millimeter. For satisfying the dynamic similarity, the velocity of water is, so in the problem it is given that oil is flowing through a prototype pipe of diameter 0.5 meter and the oil is having a kinematic viscosity, let's say mu naught, which is 1 into 10 to the power of minus 5 meter square per second, and the velocity v of oil is 10 meter per second. For dynamically similar condition, water is flowing through a pipe of diameter 20 millimeter, that is 0.02 meter, with a kinematic viscosity of mu w, which is again given in the problem 0.89 into 10 to the power of minus 6 meter square per second. So we need to find the velocity of water such that these two flows are in dynamically similar condition. Okay. So for pipe flow, the dynamic similarity will be obtained if the Reynolds number in the model, so this is the model, and in the prototype are equal. Okay, so for dynamic similarity, Reynolds number of the prototype should be equal to Reynolds number of the model. Therefore, from here we can write, so Reynolds number of prototype will be rho density of the oil multiplied by the velocity flow of the oil multiplied by the diameter of the prototype divided by the dynamic viscosity of the oil. So this is for the prototype, and this should be equal to the Reynolds number of the model, that is density of water in the model pipe multiplied by velocity of water in the pipe into the diameter of the model pipe divided by the dynamic viscosity of water. Okay, and this is for model. Now we can also write this as, we know that mu by rho is equal to kinematic viscosity. So this is the relation between dynamic and kinematic viscosity. So let's write here. This will be V naught into D divided by kinematic viscosity of oil. This is for prototype. This should be equal to velocity of water into diameter of model pipe divided by kinematic viscosity of water. This is for model. Now again we can write, so velocity of oil is given, that is 10 meter per second multiplied by the diameter 0.5 divided by the kinematic viscosity of oil, which is 1 into 10 to the power of minus 5 meter square per second. This should be equal to velocity of water that we need to find out, the diameter of the model pipe, which in the problem is 0.02 meter, and divided by the kinematic viscosity of the water, which is 0.89 into 10 to the power of minus 6. So from here, if we calculate the velocity of water, this will be equal to 22.25 meter per second. Okay, so the velocity of water is 22.25 meter per second. For detailed information on dynamic similarity, you can refer to the NPTEL course. Lecture number 48, Principles of Similarity and Dimensional Analysis, on Introduction to Fluid Mechanics and Fluid Engineering by Professor S. Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.